Hello and welcome back to Cracking the Cryptic. And I was going to record earlier today and say that whatever happened in the match between England and Germany in the Euros tonight, I hope to retain all my German Sudoku friends. And that's still the case, even though I am now recording after the match and know the result. And certainly after Saturday, I hope to retain any Swedish and Ukrainian Sudoku friends that we have, whatever the result there. Anyway, let's get away from the European footballing wars and go to Australia for our puzzle today. Jackson Griggs has sent this in as a rough sketch map of Australia in Sudoku form. You can sort of see that with the east coast going around here up to the top of Queensland in the north. And Jackson says he lives in Perth, which is about here, he says. And I guess this is Tasmania down here. Anyway, we'll get to that in a minute. I do want to mention Jovial's Puzzle Extravaganza, a series of Sudokus, one leading on to the other, that we're going to release on Patreon in 2 days' time. That's the July reward for patrons. It's going to be at a genuinely approachable level, so anyone can have a go as long as they're a patron. And there'll be a very special prize to be drawn out of a hat. We will set a deadline for that, and we're really looking forward to people getting a go at it. So that's coming up very shortly. To join all the other content on Patreon, you can find where to get that on the link under the video, which will also take you to our apps, individual URLs on Steam, Android, and the App Store for all of those. And the first link will be this puzzle, which you can play yourself. Now, the rules are these. It's standard Little Killer and Arrow rules. So Little Killer first, let's deal with that. These clues outside the grid show the sum of the diagonal they point to. That can include repeated digits. So this will add up to 17 and could, for instance, be 3, 3, 4, 7. If my maths doesn't fail me, as it did during yesterday's video. Now, the arrow rules are a slight variant on them here. So normally arrows on digits on an arrow add up to the number in the circle. So those two have to be the same digit. The same is true for this incredibly long Australia arrow, or mainland arrow, let's call it, but they add up to a 3-digit number, which is written here in left to right order. So hundreds there, tens there, units there. That's what we've got. I have no idea how hard this puzzle is. You'll be able to judge it from the length of the video, but I don't know yet. But do give it a try if you feel like it. I'm going to start now. Let's get cracking. And I just don't think these little killers are doing anything, apart from the 9 here, which has 3 possible ways you could fill it in terms of the candidates. The others are all very averagey numbers. For each diagonal they're pointing to, they average 4, 5, or 6. So that's 5 numbers, which average 6. And those are not very helpful. So I think we're going to have to look at the old Australia arrow. Now, I reckon it begins with a 1, but let's try and prove that. What is the maximum value of this arrow? 9 and 8 there is 17. There's 2 cells in the middle box, so another 17 is 34. Let's do those 3, takes us up to 58, because they could be 9, 8, 7. Those 2 could be 9 and 8, that's 75, another 24 there, that's 99. And then we're left with these 4 actually, which are in the same rows and columns. So they could be a 9, 8, 2 9, 8 pairs, which takes us up to 133. So this does begin with a 1. The only way that could be a 3 is if that's a 2 by Sudoku rules. But look, I have noticed this as I was embarking on that arrow. Lots of these digits, 4 of the digits, sit on the 28 arrow. Now, if we were assuming that maximum I was doing that got us up to 133, we'd have a 9 and 8 here, at least an 8 here, and at least a 7 there, which adds up to 32 already on a 28 diagonal. We've still got a 1 there, say a 1 there, 33, 34, and a 1 there, which makes 35. So we are 7 out. We're going to have to deduct 7 of the arrow cells on this diagonal at a minimum. And that reduces 133 to 126. But I think we can do better than that because of this cell itself. This cell itself cannot be a 1, which was part of the postulation along with 1s there. So that's taking 2 more degrees of freedom off it because it has to be at least a 3. And we are down to 2 possible numbers. It feels a bit like Vogon poetry, this, for those who are Patreons and tried that hunt. 123 or 124 must be the solution to this number puzzle. And if it is 124, then we have no degrees of freedom. No, I tell you what, we have no degrees of freedom on the non-28 arrow cells. These would all have to be maximum. I think that's how it must work. These would be maximum, but we could reduce these by 7 or something if this was 124. If, however, this is 123, these cells can have 1 degree of freedom. So let's start with, they all have to be 9, 8 or 7 now. Up. No, in fact, let's start with they can all be 9, 8, 7 or 6, which is allowing the degree of freedom. Let's take out 6 from the ones on these corners because they have to be 9 or 8 at the max, so they've only got 1 degree of freedom from 9 and 8. The same is true for this one, which is part of this pair, and these 2. And now we get a 7, 8, 9 triple in row 3, which means one of these is a 7, and these are in pairs that, to have a 7 in, use the degree of freedom. So it is used on the line. It is not needed here. That is 1, 2, 3. And now, yes, that means that this 28 diagonal doesn't have the degree of freedom. 1s in both of those are required. These other cells now add up to 23. And now we have to make all the remaining cells on the Australia line add up to 100. If those 4 add up to 23, which they must for this diagonal, then these add up to 100. I'm going to do the maths again to maximize them. So we get, actually I should have colored them while I was doing that so I can tick them off. We're going up to 100 in those cells only. So we got 24 here at a maximum. Then 17 here is 41. These 4, are 2 more lots of 17 is 34 onto 41 is 75, but one of these 3 is a 7 and therefore not maximum, so we have to take 1 off that. We're up to 74. So these 3 have to add up to 26, a 9, 8 pair and a 9. That's got to be right. 9 there, 9, 8 pair there. We can remove all the degrees of freedom. So, hang on, let's take the 6 out of there. Now, one of those is a 7. So down here, these must be an 8, 9 pair. This has to be max because we've lost the degree of freedom in this row. So that has to be 9 as well. Yeah, I mean, if we were losing the degree of freedom in this box, it would be in this cell. So that, oh no, maybe that can be an 8. Hang on. Can that be an 8? Let's just do a bit of work if we've got any. No, I don't think that 9 is letting me do much actually. Or maybe I should add this up in rows. Let's try that at a max. 9 there, 24 here is 33. 8 and 9 there is takes us up to 50. 8 and 9 there takes us up to 67, but we do need a 7 in this box. So 7 and 9 there takes us up to 83. 8 and 9 there makes 100. So that is max as well. That is a 9. Right, so that's not a 9. Now, there is a 7 in that row, but there's only one 7 in this box. Okay, so I think we've marked this up as much as I can, I believe. But I think we're onto it now. So those 4 cells add up to 23, but I don't really want to approach them yet because I don't know. I mean, I suppose what's the maximum they could be? 7, 8 is 15, and those two adding up to 8, therefore. But these could be much smaller, and those add up to much more. So I don't think that does much. Let's have a look at this 30. Now, that has to be 8 or 7. So this is either 9, 7 or 9, 8. That's either 16 or 17. Let's assume and then a maximum of 17. No, let's assume a minimum, because this is going to be high. Let's assume a minimum of 16. 8 there is 24. The most these two can add up to is 6. So that is 4 or 5. And this has to be 1 or 2, I reckon. The most they can add up to is 6, and that has to be 4 or 5. Yeah, that's okay. Wow, so there's only 1 degree of freedom along there, and that was assuming that this was a 9-7 pair, because 9 has to be included here. Okay, now what? So now we've got a 1 or a 2 on this group of cells that have to add up to 23. This could be 8 at a maximum. This could be 7. That's 15. This could be 7 is 22. And that can be 1 or 2. So there's 1 degree of freedom there. Good grief, this is clever. Right, that is 8 or 7. And that is 7 or 6. And now we've got another 9, 8, 7 triple there. How does this work? Still got 1 degree of freedom, but not many possibilities here now. I think this is right. So we've got a 9, 8, 7 set there. 9, 8, 7 set there. Those are definite. This is an interesting 7, 8, 9 that I kind of didn't have before. Now we've got to have 8 and 9 here. That doesn't quite fix this. Oh, look at this arrow. I hadn't thought about that. Those two are the same cell. Where does that appear in row 9? In one of those 3. So it's got to be 1, 2 or 3, but it can't be a 1. So we've got 2 or a 3 in that arrow. Now 8, 7, that's not likely. There has to be a 9 here. 9. Yeah, I can't quite work out how to kill off this last degree of freedom. So I'm going to look at other things until I think of it. There probably is a way at the moment. Is there anything? Yes, the 7. Oh, 8 here. Is that a problem? 8 there puts 9, 8, 7, 8, 9. I don't think it's a problem to have an 8 there, which would allow the degree of freedom to persist somewhere else. Oh, hang on, what happened here? 8 there makes 9, 7, 8. Yeah, that allows that to be a 7 as well. Doesn't fix that. What am I missing here? Maybe nothing. Oh, look, 9 and 9. So I can place a 9 down here. Where's 9 in the bottom row? 9 in the bottom row is not over there, is it? It's got to be over here. And that fixes this as an 8, which might have further ramifications. It makes this a 9, stops this being a 9 and this being an 8. It doesn't do anything else, which, oh yeah, it does. There's a 7-8 pair in row 3. This is so unexpected, some of this. That's a 9. But they're not resolved. I still haven't resolved this diagonal. But that was interesting about 9s. Now look at 8s. 8, 8. 8 has to be in one of these positions in the bottom row. 2 or 3 is there. If that had to be a 2, that would fit. Oh no, if that had to be a 1. So if they were a 2, that would fix this degree of freedom diagonal. But I don't know that that helps at all. What if this was 7? Then this would become 8. It doesn't do anything. I'm not quite sure how to get this finished off. So 9s, 8s, that can't be 9 anymore. 9 is in one of those and one of those. 9, 9, 9 is in one of those two cells. Don't tell me we're meant to be using the long diagonal now. I couldn't be. Maybe this. Now it's got a 9 on there. There's definitely a 9 here. Right, the maximum for these, no, the minimum for these is 9 and 7. 16, 25. Now these have to be 1 and 4. Yes. Right, the 30 diagonal fixed. And that took the degree of freedom here. So these are all max now. Yes. Right, sorry, that took some seeing. So that's a 9-7 pair, which fits with this having just become an 8. Yeah, that's okay. So, does that get... Yes, 8 has fixed 9 and 8 there. Actually, maybe I'd done that before, I'm not sure. 7 and 9 there. That has become an 8. That's 7. And suddenly, all those coloured cells... In fact, the whole outline of Australia is done. I haven't done the map of Tassie yet, but I'll finish that in due course. Now we know where 8 is in the bottom row, and we know where 9 is. It's there. And now we are moving. Finally, 8 in column 8 is there. And over here in box 1, thank goodness I didn't have to use that long diagonal yet, although I fear I haven't put that off for long. 7 is up there. 7 in the middle box is in one of those two positions. 9, 8. 1, 2, 3, 7, 9. So 8 is here in box 7. That fixes it in box 1. The 9 is fixed in box 1 as well. 5 and 6 are the pair remaining in the bottom row. 1. Yes, I can do 1 in row 7. It all seems to be 1s, 7s, 8s and 9s that I've got, apart from these few digits on the bottom. So I've got 4, 5, 6 set here. So that 30 diagonal is done. That 28 is done. I still don't know which the 9 is. 17 doesn't look very approachable because I haven't done much with the small numbers. So I am going to now look at this 56, which has got 9, 8, 8, 9, 7 on. They add up to 41. The other cells add up to 15. That's not very helpful. Maybe I look at minima for those. 2, 2, 2, 1. That's only 7. 8 degrees of freedom. If I look at maxima, I've got 6, 6, 6, 5, which is 23. That wasn't very helpful at all. How about this 44? I can't believe that's going to be any greater help. But it doesn't have many 9s on. Okay, so 8 there. What's the max? 6, 6, we're up to 20. A 7, 6 pair takes us to 33. Ah, these have to be the same. So the 3 and 3, 36, 39, and 6 there is 45 at an absolute max. But it's 44, so there's 1 degree of freedom. Now that cannot come on the arrow, or it would be used twice. So they are 3s. Everything else is 1 degree, has 1 degree of freedom. So 6 is the max, 6 or 5 there. Now these two, 7 and 6, so the 7 has to be on the line, and this is also 6 or 5, because it's either 7, 6 or 7, 5, and 7 can never be there. So we get the 7, and that allows us to finish off 7s. Now, can I use, 4, 5, 6 triple, so there's a 4 there, not there. 1 and 3, yes, we know this is a naked single 3. 1 there, 1 here. Oh, it looks like 1s are suddenly finished. There they are. How about 3s? There's a 3 over here somewhere. So 3 up here. I don't think this is quite as profitable. 3 in one of those 2 cells in the central box. Now, is there somewhere here where these two have to be the same? Because then they are going to be 6s. But I don't think it's obvious that that is the case. Let's go back to this 56 diagonal, especially now we've got a 1 on it. So 1, 10, 17, 25, 33, 42. We've got another 14 to go. It's still so averagey. 14 in those 3 cells. The minima are 2, 2 and 2 is 6. That's useless. The maxima are 6, 6 and 6. So that adds up to 18. That's too many, but only by 4. And if they were 6s, all of these, well, no, let me just colour those now. If they were 6s, that would be a 5. That would be a 5. That would be a 5. So there's an effect on both of these. Okay, so now what I'm going to do is try and add up this whole section, which has to add up. That's those 2 diagonals. That has to add up to 100. Maybe 100 is the theme of this puzzle. Anyway, in the numbers that we've definitely got, 9, 16, 25, 32, 40, 43, 51, 54, 63. So these other cells add up to 37. And these 4 add up to 24 or 23 of those. But maybe I just need to think about, what's the total? 37 for the green and orange. 6 and 5 in that box is 11. 6 and 5 in this one takes us up to 22. 6 and 5 here takes us up to 33. 6 there takes us up to 39. So there are only 2 degrees of freedom on the maximum for those pairs. I don't like that, because that means these greens can be 6, 5, 4 or 3 effectively. If the oranges were 6s, apart from the one of them that's a 5, say that one, then these could come down, one of them to a 3 anyway. That can't be a 3 because of this 3. I think I'm missing the point here. Hopefully not hard. Let's do something else. That can't be a 3. How about that? So that's not a 5. Because we know 3's in one of those 2 positions. Anywhere else where, yeah, 3, 3. So one of these is a 3. That can't be a 4. That's worth knowing. 4 is in one of those 2 cells, just regular Sudoku. what's going on? 2 is in one of those two now because of what we did here. Maybe we need to think about 2s then. Not really. There's just not much else going on with 2s. Oh, what is happening here? 2, 5 or 6 there. 2, 5 or 6. 4 being in one of those. I feel I'm on the right track here. Only one of those two could possibly be a 3. Now that can't be a 3 because of this 3. So if that was a 3, everything else would be max. We'd have 6, 6, a 5, 6 pair and a 5, 6 pair if that was a 3. What good would that do me? That would be a 2, 4 pair. Still have 3, 5 and 6 to place up there. I'm not seeing how that resolves. I'm probably missing something very blatant here. I'm sorry. 9, 8, 1, 3, 7. Oh, I haven't looked at this 17 diagonal like a Muppet. 7 there. So these add up to 10. They can't include any 1s, clearly. These add up to 10. What good is that to me? Doesn't stop one of them being a 6 even. That's very annoying. I mean, there's no number that's getting ruled out there. Oh, I thought that was going to do it. Good grief. That can't be a 6 actually, because it's seen by 2 of these oranges, and one of them must be a 6. 2, 3, 4 or 5 there. I don't know, I don't feel I can use this. It's not enough. That can't be a 6 because those 2 would have to be 2 and 3 would have too many. But I mean, I can't just pick off cells that can't be 6. Oh, mind you, I've got a definite 5, 6 pair because that cell, because they can't be 3 or 4. Oh, that's surprising. So that is 2 or 4. That is 2 or 3, and this is 2, 3 or 4. That's 2 or 3 as well. How is this going to help? Five, 6. How many degrees of freedom did I have? I had on this very few. Let's look at the max again. Sorry, I've forgotten the number. 15, 16, and 11 is 27. 6 there, 33. 9, 7, 6, 8, 5, that's 35. So 68, 71, 79, 82, 91, 102. And I'm looking for 100 from 56 plus 44. So it's 2 degrees of freedom. And one of those is on the orange diagonal. Is that right? And one is on the green? So that can't be a 3, if that's right. Let's try it with this. I think that is right. Let's try it with that being a 3 and everything else absolute max. 11, 12, 18, 25, 31, 40, 47, 58, 66, 69, 77, 80, 91, 100. Oh, bother, it can be a 3. But didn't I just make it 102 at the max? So there's 2 degrees of freedom, but surely, okay, it's 102, but one of the degrees of freedom has to come off the orange. So only one comes off the green. So although that could be 5 at the max, it cannot be 3. That is right. And I'm failing to take 3 out. So 3 is here. Good grief. Oh my goodness, I see. So we get a 3 in this, not in this cell. 3 is here. That is on the diagonal. So we get a 5. That can't be 5 now. And there goes the degree of freedom on... Well, 1 degree of freedom is gone there. No, it's not. That could be 6 and that could be 5. So no. Well, that would take the orange degree of freedom. And if that's a 4, that's taking too many degrees of freedom, surely. Oh, I'm not sure now. Okay, let's see if I can just get further with what I do know, what I do understand, which has been precious little in this puzzle. Oh, it's a very interesting puzzle, but I am not having an easy time with it. And that couldn't be more clear. Right. Oh, I'm going to have to... what about that 17? What's happened to this? Right, these are from 2, 4, and 6. So they're even, and that's odd. This has to be even. So it's not 3, it's 2 or 4. 7, and these add up to 10. And there are various ways they can do that. But we know where 3 is here now. So that's not 3. So 3 in the middle box is there. Let's get rid of the corner marks, which have done their job. So 3, 3, and that's the last 3 in the grid, maybe? Okay. So there's a 2 here. Oh, I can't. Right, let's just add up this at the max now. But the trouble is the max is affected by the orange. 17, 34, 35, 42. Another 14 in the green. But only one of them can be a 6. I don't know what to make of that. A maximum of one of them can be a 6. I don't know how to deal with that. Right, never mind. That is a 2. I've suddenly seen that that is clear by Sudoku. That's not. Now, what about this 17 diagonal then? This is at least... if that was a 4, this would be a 2, and that would be a 4. If that's a 6, this can't be a 4. If that's a 4, so this can't be a 4 either way. Because that would make this a 6. And we'd already be up to 17. So that's not a 4, that's a 2. Good grief. So we get a 2 in the top row. 2 in one of those cells. I mean, look. If you want to criticize me for solving this puzzle, I can take it, because I don't think I've done much good here. Look, I've got a 2 pair looking at that cell, so that's a 4. So now I can do this diagonal. That is a 4. 6 there. Now this is a 4. Right, now let's add it up again. 4, 11, 21, 29, 38, 46. I've got another 10 to make. So this can't be a 6. I know that suddenly. 10 to make from the green cells. And in the oranges, 3 of them are 6 and 1's a 5. And by goodness, I'm barely advanced. 5 or 6, we get a 4 here. That makes this a 2 and that a 4. This can't be 4 anymore. So that is a 4. So that's a 6 to make the maths work. So now we know where the orange 5 is. The other orange is a 6. Please let this work and be right. 2 and 5 there. I am absolutely shredded by this. And I don't know, maybe somebody who could see a bit clearer would do that a lot quicker. I'm pretty pleased to have got to the end of it at all, frankly. A matter of perseverance, as sometimes happens. 5 there, 4 there. We get a 5 here. 2 and 6. 2 and 5 and clicks the tick with trepidation. I think it might be worth, I'm just going to take the colouring out, might be worth just checking these totals one more time. 11, 21, 27, 35, 43, 47, 56, 8, 14, 20, 27, 32, 35, 38, 44, 18, 25, 29, 30, 4, 6, 10, 17, 9, and 28 here, 9, 17, 24, 25, 28. Whew! That's a relief. Lovely puzzle, Jackson. Thank you very much for sending it to us. As I say, I don't think that was the best solve you could have got of it, but it is a correct solve, and I'm happy enough with that. Really interesting puzzle. Let me know in the comments what you thought of the puzzle particularly. Compliments for Jackson, very welcome. And I will see you again soon on the channel. Bye for now.